live, and we'll starting soon.
Great. Yeah, and then you can send the YouTube link. Sergey, how are you? Do you want to say hello just to make sure everything's working?
Yep. Hi, everybody. Nice to meet many of you. Good to see some of you that I already know well. Thanks for having me here at your kind of meeting workshop planning thing.
Yes, thank you for coming.
Yep, my
Sergey,
pleasure.
just to let you know, we'll start with you. Just you can talk for a few minutes, and then if you need to get going, it's fine. We'll continue to talk about it and have questions and things about it.
Yeah, sounds good.
But you are free to stay as long as you want. We're not kicking you out or anything. I'm just saying if you need to leave, you can.
Good to know. I appreciate the flexibility. I might need to leave for a meeting, but I'll be glad to be as helpful as I can be. So, I think the first thing that I'll start by saying is that I'm a big fan of ENS, and I've been a big fan for a really long time. I've tried to support it however I can over the years. Ever since Namecoin came out as the first thing after Bitcoin, I was always fascinated by the namespace problem around blockchains. And I think, Nick and all of you have done a really great job at turning ENS into what it is today. I think the talks about collaborating with ENS and the protocol and the community and so forth that I've had with Nick and a few other team members has really been around how do we get ENS working on various layer 2s, and then eventually how can we get ENS also working on various chains, and to make it a more widespread kind of solution. We use it ourselves for data.eth. So the registry we have for people to get a lot of data, and to access that on chain is through ENS, because the security of being able to see that is, I think, very important. So I really appreciate the way you guys have been building this, and I think its expansion into various layer 2s has benefits for those layer 2s, but I think it also has big benefits for the scalability of ENS as a system, because the scalability and the better cost structures of those layer 2s give ENS a new level of usability and scalability and so on. So, that's kind of the body of work that we've been collaborating on, or doing our best to collaborate on with, Nick and the rest of the folks at ENS that we've been talking to. Generally speaking, that collaboration has been around CC, other than the registry stuff and other than a few other things that we're working on how to help make ENS as secure as it can be. The work around CCIP is really the topic for today. So CCIP is, okay, I can't screen share. That's fine if I can't, but
Yep, you can. Here, let's just make sure.
I can do it. Hold on a sec.
Yep, sorry, we just have to change a quick setting.
Okay, great. Thank you very much. I appreciate it.
Yeah, I just changed.
Great, thank you. Great. So CCIP is the cross-chain protocol we're working on. It's being built by folks like Ari Jules, who was previously the chief scientist of RSA, who has been the co-author on our initial white paper and on our second white paper as well. It really focuses more than anything on messaging, and it's also being built by somebody called Ben Chan, which some of you might have spoken with, who was previously the CTO of BitGo and is now our VP of engineering at Chainlink Labs. So the focus of CCIP is on messaging and on having both read and write functionality. You folks initially need the read functionality, which you've done a good job at kind of speccing out and building to a certain degree. And I think the collaboration we're looking at doing is how can we together help build that read functionality in a way that solves your immediate problems, while eventually giving you folks at ENS a write capability as well to do some even more advanced things when it comes to going to other layer 2s and other cross-chain systems. Generally speaking, in your scheme to go to various chains, there's also a need essentially for an Oracle or an Oracle network, or somebody that's responsible, in your system, they're called gateways. For us, they're Oracle networks that are responsible for kind of finalizing the read or write function. Initially for you guys, it's the read function, but kind of instantiating what needs to be read or what needs to be written onto the other layer 2. And so the same security that secures anywhere between 40 to 70 billion in DeFi is kind of the same security that would be applied to guaranteeing the proper messaging and the proper execution of ENS related kind of events on various layer twos. We're already integrated into Optimism and Arbitrum. So we're already live in those layer twos. We're going live on many various chains in layer twos. So beyond layer twos, there's also the dynamic of how do you make ENS, a namespace for various chains and various other layer twos beyond Optimism and Arbitrum and so on. Generally speaking, our focus is once again on messaging, because we think messaging is at the core of what people need to do. Messaging can extend to what you folks need to do. It can extend to token movements, which eventually you guys might find useful depending on how you want to approach tokenizing domains or something like that. And generally speaking, that's the larger overview, right? So I was told that I could just kind of come in, explain some of this stuff at a high level, and that in and of itself would be useful. Generally speaking, our goal is to get ENS onto various layer twos that we're already live on and so have a lot of experience with. Our goal is to take on any solutions work that ENS needs for going live on these, various L2s and various other chains to take that burden off of the ENS development team. And beyond that, I think there's a medium-term and longer-term world where you folks need additional write functionality, which we're working on with CCIP. And I think our collaboration around the read functionality is already going to be very fruitful for everybody. So I really appreciate Nick and everyone else working with us on getting, CCIP working the right way for ENS and allowing it to do what's needed for getting, ENS to scalably go on to these other layer twos and eventually these other chains. That's our fundamental goal in this collaboration. And I'm thrilled to be a part of the ENS community and be as helpful as we can be for having ENS securely reach these goals. So always been a big fan once again. So
yes,
that's the
Sergey.
brief.
Yes.
Yep, of course. So great. That's the brief overview. If there's anything else, glad to jump in, but glad to create that brief context.
Yes, thank you. So yeah, bottom line here, which we'll be talking about here now the rest of the time, is that what we were calling Durin is now going to be renamed CCIP, and Chainlink really is going to be working with us closely to further flesh that out, to develop it, and to help it get adopted and things like this. So we really appreciate the Chainlink community and their support for this, because obviously they're experts in this type of Oracle type stuff. And so yeah, so what was Durin, if you'd heard that term, is now CCIP.
Yeah, that's right. So there's a portion of the CCIP protocol that's related to read functionality. That's the place where you guys kind of started off. And we've always been really thrilled to collaborate with Nick in any way possible and with other folks on your team. So we're just thrilled that basically we can now both be collaborating on making CCIP kind of a cross-chain standard that has both good read functionality and good write functionality. And so you folks have already done some of the work on read, which is great, and which we're going to continue to help support and improve. And then the write functionality is what we've been working on, which you guys would need in the medium term, and is complex in its own way. And so at the end of the day, I think ENS basically gets a great cross-chain solution that allows it to expand to layer twos and eventually other chains with an efficient network of oracles that make sure that the standard that's used to make that work is actually backed by high quality oracles.
Yeah, and I just want to say thank you, Sergey and Chainlink, for collaborating with us on this. It's going to make it much more practical for what was Durin and is now CCIP read functionality to get widespread penetration and good sort of enterprise grade support. And it's going to make it a lot easier for ENS to roll out L2 support in a timely fashion with robust gateways or oracles. So thank you.
Of course, thank you for collaborating with us. It's our pleasure, and I think having a decentralized namespace is absolutely critical to how things need to go. And I'm just glad to have a way to help contribute to that and help make it part of the decentralized infrastructure in the future. So thank you for collaborating with us as well.
Cool. Thank you, Sergey. So now we'll be back to the, let me share the screen now for the progress update. Can you guys see my screen?
Yes, we can see it.
Yeah, okay, cool. So this session is kind of, I'll do the first half of just like half recap of and the half progress update of what we have been doing in, used to be called During, now it's called CCIP Read. And then another half, Nick will be kind of guiding us, discussing like, basically we built some of them to prove it works, but there's still lots of things we have to solve. And part of the obstacle will be solved in collaboration with Chainlink, which is great. But he'll basically steer the conversation of what we need. And also this L2 will require lots of change in the entire ecosystem. So hopefully this can give the place to discuss what exactly we need for the help from other ecosystem partner or like dApps who have already integrated with us. So let me start. Yeah, so architecture recap, CCIP read integration demo, and discussion topics. So first it's me, and I am aware that some people are not technical. So before I go a bit go deeper in the technical one, I think this is a one slide kind of non-technical people should be aware of, is that our L2 is not like, for most of the L2 solution in other dApps is more about whether the protocol or dApp either choose to go to somewhere or choose to go everywhere. Whereas in our case, we provide a kind of common framework and the tools to let dApp who integrate with ENS to choose where they store their kind of data in the L2 or even off-chain, so that they can kind of benefit the scalability benefit they can gain from the L2. So in what it means is usually that, so I think Bradley most briefly mentioned that like, this is not about making the .is registration cost cheaper, but it's more likely that there's a resolver where you can store like text record or address space. The resolver, we have a generic architecture that at each the domain owner, like if I have a name called matoku.is, so matoku.is can point to specific solution to do the name resolution, and we have a domain specific ways to upgrade, how to kind of upgrade itself. And the gist is we want all these dApp to decide which L2 to choose. So in this example, what I kind of mentioned is like, for example, like DYDX is known for staying in the stockware. Then in that case, sorry, I'm getting lots of notification. Or maybe Nick is trying to say something because I'm getting lots of messages. Are you trying to say something, Nick?
No.
Yeah. Okay, good. Because I got like flood of notification from Nick for some reason. But anyway, yeah. So for example, stockware, they already exist in the DYDX exists on stockware, and then in that case, they already have the whole UI around how to update the data on their choice of like layer 2. In that case, what we want, we haven't had a conversation with DYDX, so we are just hoping something like this is that like we would like them to issue subdomain under DYDX on L2. So if in case of Uniswap currently runs on Arbitrum, but also in Optimism. And in case of, so one thing critical is they kind of have to decide, they could go to different chains, but they kind of have to decide where they issue subdomain. So in this case, maybe Uniswap may choose to use Optimism to issue subdomain. That's where people can issue subdomain. And they're also like, I think Reddit announced some partnership with Arbitrum to do. So that's why I put it that like they could issue subdomain there. So that's kind of concept of ours. And if you go a bit deeper in the technical level now, is so resolver, so we have a registry where it's a basically big dictionary, like where it has a key, and instead of having the value to return, it returns a resolver, so-called resolver smart contract. And that smart contract usually returns the same address, but with this CCIP read, now it returns the address of some web services. And so in this example, what I think after the last April's meeting, Nick did define a new standard, and I think I have a EIP somewhere that, for example, in this case, so resolver has a function called address, and which takes byte-32 node as argument, and it returns address. We want to keep that interface so that you don't have to have switch API or anything like that. So instead, what we propose is basically raise a custom smart contract, custom contract error, which is new feature from Solidity 0.8, but you can kind of use it even if your Solidity contract is not in 0.8, and to raise a error where it shows the basically the gateway URL. Then that gateway URL is in charge of calling L2. In this case, we have a L2 has a kind of similar things as what we already have in L1, which just returns address. But when it returns with address, it kind of constructs a proof which you can validate in the L1 we have a convention that, like, if the function you want to call is or address, will have a convention specification to have it basically append with proof. So like it's going to have app with proof, and this is a code of the how to use in optimism, but like there's ways to basically pass a proof, and you can verify on L1. So that's kind of base. We kind of proposed back in April, and I was kind of working on basically Nick already had some prototype on their project, so I tried to port that proof into the Dream framework itself. And I'm not sure how just showing the YouTube video on the Zoom call would ever work. So if it doesn't work, I'll also maybe I should, layer 2 section with a YouTube link. So if you have problem seeing it, you can just watch it later. And by the way, can you guys hear and can you see?
We can see it, but we can't hear your narration.
Oh, really? Okay, then I'll try to. That would be super hard because I can hear what I'm showing. I can mute, and yeah, so I can just guide through while I'm running the video. So this is a very simple example from the JavaScript side using ESAS.js, and you put basically the resolver address and the API to create a resolver contract, and usually it has a basically and the path provider, and you call .addl, and that's a simple example. And so if and this is a demo of the on the top right, there's an optimism log is running, and on the bottom right side, there's a CCIP read server is up and running. I added a bit of debugger message so that it kind of shows some additional message. And on that point, on the left side, I created a kind of script which runs the code which I just showed you. And if this client is not aware of during, what it does is just return the exception that it says, it says ADDL, return the error, and it's called error name off-chain lookup. So this is, if it's not integrated, it just like blows up. But what it does is like, now I will go back to the code, and I'll show the one integration example, which could work is that basically you include the it's a jury middleware, but it's actually CCIP read middleware it's going to be. So if you create the, basically require it, and you pass the provider, which you might go from a JSON RPC provider, then you wrap it, and you then pass that wrapped provider back to the resolver. So this is pretty much the only change you have to do, hopefully. And if you run it again, this calls is just return the ECM address. And on the right side, what you can see is that, let's just stop it. And if you go back, if this address is that, yeah, I think we mentioned about when it calls, before migration, this just raised the error. But now inside the middleware, it kind of extracted this dance of going through between L1 and L2, or in the provider, and also calling this. It's all encapsulated in the provider. And also, this is not just for the provider for ESAs. It should be compatible with any JavaScript-based provider. So you should be able to just pass provider to Web3.js or anything else, and it should work. So that was basically very simple demo. And with that in mind, now I'll pass it to Nick to guide the discussion.
Sure. So hopefully you guys have a reasonable overview of how CCIP read, still going to trip up on that occasionally, but functions. And the stage we're at, which is that we have a prototype implementation, we have both a server framework, which permits easily writing gateway services, and we have some middleware which enables basically adding CCIP support to any Web3 app transparently. The quite neat thing about this is that calls look just like regular Web3 contract function calls, but transparently behind the scenes can go off and fetch data from an external service and verify it. So we have a very basic version of that functional, and our next work is to productionize all of that. There are a few open questions, and this is the sort of area where I'd really welcome input from workshop participants. First of all, different L2s are going to have different implementation considerations. So, for instance, with Optimism, the natural way to do it is your gateway answers a question like, please provide proof of the contents of a particular storage slot on Optimism. And it responds with the contents of that slot and Merkle proofs up to the state root of Optimism, proving that that's the case. And then those can be compared to Optimism's L1 contracts, which contain the state roots. But different types of L2s are going to have different requirements for this, and different people are going to have different trade-offs. So, for instance, with Optimism, you could choose that you want to wait for a finalized state root, or you could decide that you're happy with something that's been submitted but is still in the dispute period, depending on your trade-off between security and recency. And so I'd be really interested to hear from anyone in the workshop who is working with other L2s, or for that matter, non-L2 platforms, that has a set of constraints in mind, that knows what they want from this, and what issues they might be implementing it with CCIP. Secondly, there's non-ENS applications. So we'd be really excited to talk to people about what other interesting things we can do with this. Makoto's put together a demo, for instance, with like a token airdrop style thing using this, that enables doing all of that transparently to the user and in fact to the app, without having to, so you can consult an L2 without really having to code that in on a per app basis. Thirdly, how we can design more generic gateways, because our goal would be that the gateway can be a fairly generic API that contracts can access, rather than having to write a specific one for every application. And finally, thinking specifically about ENS, on different L2s, how users can verify, for instance, that their subdomains are secure, which is something you can do on L1 with the name wrapper and so on fairly easily, or at least our code can do it fairly easily for you, but will be a little trickier with different implementations of subdomains on L2s. So first of all, I guess, is there anyone here in the workshop who is working with L2s other than Optimism, or is working with non-L2s that they would like to use this to interface with, who has thoughts on different implementation considerations?
I'm Stan. I work on the casing. It is a zero knowledge ZK. It is a ZK rollup. So I think that verification of state, proofing of a storage slot will most likely work almost the same way as Optimism, probably the same. Maybe the only difference is that the hash function which is used for the tree, most likely will not be like SHA-2 or SHA-3. I don't know, what does Optimism use for the
Optimism uses KECAC, the same as the EVM.
Oh, I see. For the rollups, it will most likely be some algebraic functions. I think it shouldn't be any problem at all because it will be a read call, right?
Yes.
Oh, then I guess it will be almost.
I guess the sort of the stretch goal for us, which I'd be curious whether it's practical on a ZK rollup, is that you could actually verify the output of running a read function on the L2. So rather than a proof of a particular storage slot, you get a proof of the result of running some function on the L2. Do you think that would be practical?
Proof of running some function on L2? I'm not sure. I think it would be just a lot easier to verify storage slot.
Fair enough. Yep. And Nick, for our first iteration, that's kind of what we're going with.
Nick, I'm just not sure. So Louis from Starkware, I'm not sure exactly what you want.
Oh, sorry, you cut out. Are you there?
Yeah, I don't hear him. Oh, did you just come back?
Yeah, just a second. Changing connection, and we make my comment over StarkNet.
Okay. So we've got ZK Sync and StarkNet folks here, which is great. Is there anyone else representing an L2 on the call?
There's a couple of Optimism guys.
Yeah, Elida from Optimism here.
Hi. I guess we've already covered your bases since Optimism's what we've been using for some of our prototyping.
Quite well as well.
Yeah.
Thanks, Nick.
My pleasure.
So I have a bit of connection.
Yes, wonderful.
Yeah, fix it. So could you elaborate? I'm not sure I understood what you want to verify on the L2, and I just want to make sure that, could you repeat to see how it would behave on StarkNet?
So effectively what we need is a function that can run in the EVM that accepts some sort of proof generated by the L2 and verifies that it's accurate. So in the case of Optimism, for instance, it gets a proof of a storage slot. So it's the contents of the slot, and then the Merkle proofs all the way up to the state root, proving what it is. And then we have a function that's written in an EVM smart contract that verifies those proofs and returns the contents of the slot. So we need some sort of equivalent for a ZK sync-based, or sorry, a ZK proof-based L2 that some piece of state holds on the L2.
So I'm not sure where the data come from, if it's coming from L2 to L1 or L1 to L2. That said, StarkNet does have KCheck. It's not recommended to use it because StarkNet has KCheck, but we obviously prefer to use another hash function if possible.
Yeah, no, this doesn't have to be specifically KECAC. The basic idea is suppose I want to issue subdomains on StarkNet. I set up some form of system on StarkNet, like a smart contract style thing that issues those subdomains. And then I need some way to prove that a particular subdomain has a particular resolver on StarkNet to an EVM smart contract. So we can...
to an EVM smart contract on L1.
Yes. And so then you make a read call to that contract and you supply whatever proof data is appropriate, and it has to be able to verify that proof is, that state is part of the L2 state using whatever sort of anchors there are on L1.
I have to admit, I'm still confused by what you described you call proof in this context, because from the perspective of L2, we just have a communication bridges where message can go from L1 to L2 and L2 from L1. Whatever the L2 would state will be true. I mean, from the ZK rollup would be true, and output as such as a message from L1 to L2, from L2 to L1.
Yeah, so the purpose here is to avoid the need for an explicit message send operation from L2 to L1, because if you have to do that for every subdomain you create and so forth, you end up incurring L1 gas costs for everything.
Okay, so what you're saying. So now what I can tell you is we also have storage proof, as we have full support of storage proof of Ethereum-based state, meaning that you will be able to prove any arbitrary block of ETH in slots on StarkNet using storage proof, which is what we're going to use for Stark Vote, if you're familiar.
What about the reverse, though? Can I prove to the L1 EVM that some state is held in L2?
Yes, also, but you will, of course, yes, you would. You need to implement it's a view function, I guess. Yes, it's easy to do, and it wouldn't be costing any gas if it's a view function.
Awesome. Okay, so this is the base assumption we've been operating on for our L2 functionality, is that we can do something like this with pretty much every L2, because of course they have the underlying layer generally has something like this to facilitate messaging anyway, and I'm glad to hear it holds for at least 2 different ZK based rollups. So we'd love to speak to you guys maybe asynchronously about like how we can start to prototype a gateway to your L2s with the system. So Makoto, did you have that slide with the other discussion points? Because my not yet had coffee 7:30 in the morning brain can't remember what the next point was. Right, so the second one was non-ENS applications. So what we're developing isn't we're standardizing it as an EIP. It isn't just for ENS. It's a generic system for effectively doing look-asides for a contract can specify. In order to answer your query, I need data from an external source, and then your Web3 client, such as Ethers, goes off and fetches it from somewhere else and then returns it to the contract, which can then complete its computation, basically. And so I'd be really interested if anyone on the call has other applications for this in mind. As I said with Makoto, we've prototyped a demo that uses like an airdrop type setup, but I'd be interested to hear from anyone who's working on or is interested in other things that apply. Anyone?
I have a question. How does CCP actually work? So it's like a simple Web3 provider asks a view function from a smart contract, and then whenever the smart contract wants to call some L2 or some other chain, it has to like call the chain itself by itself and then return back the values. How does it work? Or it's asynchronous?
It's asynchronous, yes. And the way it works at the base layer is you call the smart contract and it reverts with a custom error. And the custom error contains the the gateway URL that you should call and the data you should provide to the gateway. And then the Web3 library, such as Ethers, goes off and calls that gateway and gets back response data, which it then passes back to the original contract.
Oh, I see. Thank you.
And so the neat thing there is that you can implement any proof system you want. So in our examples, we've been using Merkle proofs and so on, but another example would be that if you want to issue subdomains to your users and you're a wallet, for instance, you could just publish your own Merkle root to the chain, or you could even just use signing with a trusted key, whatever sort of security trade-off is appropriate for you and your users. And so you don't even have to use necessarily an L2. You can use sort of any off-chain system. You just get whatever security guarantees come with that. Effectively, this adds no additional trust assumptions, and it's up to you to pick which model is suitable for you and your users.
I mentioned to Nick that I think I could see DIDs, so decentralized identifiers. So it's coming more from an identity perspective. I think the longer we all operate in the space, the more certain concepts are converging in terms of like, okay, you can have multiple owners behind this. You can register like an encryption key or service endpoints. It's not that far different than a profile where you can register other things or like an NFT. So all of these are conceptually like something only once exists. And so I could see that the DID ecosystem could work very closely with you guys, because I think conceptually trying to achieve the same thing. I know that's at least one thing I'm very interested in, and in particular in that case with the CK rollups, because I think the properties on non-fungible stuff are more interesting in the CK rollup world, because it's a way more specific problem rather than a very generic I don't know, smart contract or a logic to convert that to.
Yeah, I'd also be interested to see the applications of DIDs to the sign-in on Ethereum stuff. I'm not intimately familiar with the DID spec myself, but it seems applicable there as well.
I think that's part of like when I mentioned in the earlier session, I'm the pain. I was one of the people who said, let's go to the next level and use DIDs, because I feel like it is what the other hundreds of companies are building worldwide, and including like Microsoft and others are building like DID login. So I think that's kind of like, I think what we are going through in the signing with Ethereum discussion. So I don't want to derail it here, but it is obviously very close to our hearts too, to bring this together in some.
Yes. So I guess nobody else has comments on non-ENS applications, which I guess shouldn't be an enormous surprise since this is the ENS workshop. The other one of the other issues is design of a generic gateway interface. So far, our gateways have been orientated around a specific application, so they get sent a query to say resolve address X, and then they go off and they do that by fetching storage proofs and so on. We'd like to see more generic gateways, because that way a single general gateway service can be operated by Chainlink or by us or by any independent party that can be used by a variety of applications, rather than having to deploy a bespoke gateway for each different system. And so a really basic version of that will probably just look like fetching storage proofs, like one or multiple. And a recent change to the spec that we're writing facilitates that, because now the contract can specify the call data to pass to the gateway, whereas previously it was always the same as the original call data to the contract. But I'd be interested to hear any feedback anyone has on what a better generic gateway would look like. And when I say generic, I generally mean generic to the application that's calling it. So whether it's ENS or an airdrop or something else, rather than necessarily generic to the chain it's on, because I think every gateway is going to have to be specific in its implementation in terms of what the proofs look like and so forth. All right. And so the fourth point, which I'm hoping to get some, sorry, somebody wanted to.
I just wanted to say that I might get something wrong, but I think that generalizing the gateway, at least the data which should be sent, should not be that hard, because most of the chains that we're interested in are Ethereum compatible or at least easily convertible to the ones. So I guess calling will be more or less simple. And regarding the proofs, the state of any L2 or at least L2, I don't know about any sidechains, any most sidechains, but it usually can be proved with some Merkle proof. Just return an area of storage slots which should be proved from which the execution was derived. So don't think it should be that hard.
Yep, it's. I mean, as a sort of a stretch goal, I would love to see a higher level interface than that, because fetching storage slots still makes the low level details of the EVM part of your application's interface, which is unfortunate. And we don't really have a better primitive than that for now. But if there are ways we can do things like prove the execution of a view function, which is much more difficult, then that would enable both more generic applications and ones that abstract away the implementation details. Like, it's kind of unfortunate that at the moment this will require that the contract on L2 to issue ENS names has a particular storage layout, so it can't take advantage of optimizations that might otherwise be available to it, and so forth. So the last point I wanted to bring up was the UX, effectively the UX concerns here and the challenges we're going to face, because with the name wrapper, we're going to have an excellent way to make it very easy for users to determine that, oh yes, if I buy a subdomain off this person, I know my name is secure. I know they can't revoke or replace or rewrite it. But doing this with L2s is going to be a little more of a challenge, because each L2 may have specific implementation concerns and so forth. And so to a degree, we can write sort of official L2 resolvers and L2 systems that enforce those same guarantees, and we can check them across our manager interface and so on. But it's not going to be practical for the manager to support every single potential L2 integration or every single potential sort of off-chain integration. And in some cases, users may simply be relying on the trustworthiness of the person who's issuing the subdomains. If Google signed up to issue ENS subdomains to users, they're mostly going to rely on their own trustworthiness to do this, rather than have some cryptographic proof of their inability to replace the subdomains. But I'd be interested to hear from anyone how you think we can best convey to users and this sort of applies both to L2 stuff and just to the name wrapper, best convey to users what the security constraints on their domains are and what the guarantees they can rely on are, and how we might enforce or message that across different L2 implementations.
Yeah, absolutely. Nick, you mentioned me, right? You mentioned my name?
Not explicitly, no, but I'd still love to hear your feedback.
Sorry, I thought you mentioned my name. Sorry, I'm in like 3 meetings at the same time, so I really apologize. I'm sorry. I thought I heard my name, but in any case, I think it'll depend on the amount of chains that CCIP creates connections to, and then I think it'll also depend on the guarantees of each chain. Some chains are different in terms of what they can verify, so there's some variability there. And then I think a lot of it will depend on the quality of the Oracle network powering a certain bridge, because even if you have an integration, and even if you have a protocol of some kind, like if people are pretty sure that the Oracle networks are able to move things around and the integration is into all the chains that they want, I think there will be like a minimum for the quality of the Oracle networks that transfer anything of significant value. That's more to security. And then the breadth of where it goes is the amount of integrations. I don't know if I'm answering your question, though. You seem to be asking about how do they know that, like, what are they trying to know?
Well, so this raises an interesting extra dimension. The question I asked was specifically about, say I own wallet.eth and I decide I'm going to let people have subdomains of wallet.eth, and I'm going to save gas, I'm going to do that via Optimism. We need some way to show users whether they're relying on my honesty or not, or whether there's some guarantee that once I've issued somebody a wallet.eth subdomain, I can't take it back. And so we can do that now with the name wrapper on L1, but it's going to be more of a challenge to do this across multiple L2s where there might be multiple implementations, and we're going to need to implement similar constraints on the system on these L2s. But the interesting extra dimension you've raised here is that in addition to those constraints in the system, there's also conveying to users what the trust model of the actual bridge is, because in the case of like a bridge to Optimism, it can actually be trustless, and you can say there are no additional trust assumptions. In the case of a bridge to say Polygon or something like that, you may be relying on a consortium of signers, and I think it's relevant to convey to users that this is the risk model, however low, that it's a different model to a trustless one.
I get your question. Sorry, I get it now. I think you would have approvals. So you would have a contract somewhere that controls the approvals, and then the subsequent contracts on the L2 that issue the subdomains, they would need to go through that approval process. And then you would need messaging to make sure that that approval was verified or approved, right? So you would basically need a cross-chain transaction wherever the approvals live. The approvals could live in like the main chain, which I'm thinking in this case would be ETH, or it could live in the L2 where people issue the subdomains, but probably just some kind of scheme around the approvals that you can't do certain transfers without those approvals, and then you would need to message around that. Does that make sense?
I think that's a technical solution to the sort of the low-level problem, but the question is like, if we're building a generic manager, how do we verify programmatically that the particular name the user is looking at is using that scheme and is not, or is using some kind of safe scheme? Because we can't rule out other people bringing up their own gateways and having their portals to their own systems. And maybe the answer is just that we manually add support for the ones we understand, and the others we just show users a warning saying, hey, you can do this, but we don't know how secure it is. It's up to you to find out. But I was, hoping perhaps that somebody might have some inspiration on better ways to message this or better ways to do discovery on this.
I feel like at the moment there are like two different at the moment in the market. Like for example, like L2 beat. I think the overview of what the risks are per different L2s. That's more a classification of the L2 itself. I think it could be expanded and potentially operate as at least a trusted source of some form. Not that you need to trust it, but more for information purpose trusted, not in like technical terms. And the other thing, what Uniswap is doing, that you want to trade certain tokens. So if you want to operate with an L2 through a bridge, which might not be like a well-known one, you could still allow it, but it might not, like you need to have an extra confirmation like, hey, this is an unknown bridge contract for us. Be extra careful or check out A, B, and C. I think that at least are two practical mechanisms which we could adopt.
Yeah, those seem like good mechanisms to borrow too, yeah. You also asked on the chat what the risk is from the Oracle aspect. So at its base, if you're integrating with something that supports a trustless bridge like a true L2, like Optimism or ZK Sync, the only thing the gateway or the Oracle can do is be unavailable, so effectively censorship. Yeah, if it provides an answer, it has to be an accurate one because the contract can verify that. If you're building a bridge to something else, like say Polygon, then the Oracle or the gateway may have more flexibility to mess with you.
Okay, I think that's why we might need to be a bit more specific as a community If we're talking an L2 conversation here, then I would say it's just censorship. If it's sidechain type things, then additional risk come on top. And I think hence why I was referring to like the L2 beat website, which at least like indicates what kind of technology is behind it. And that implies certain additional risks or less.
Yep. And there's an additional complexity here that depending on the platform, the security guarantees of the gateway might be different from the security guarantees of like a different bridge. So, bridges to Polygon are typically operated by some sort of consortium of signers, but that bridge might not be offering like this CCIP messaging service, and therefore it might be a different consortium of people who sign those messages, and therefore different security models, which further complicates things.
Can I ask one, since Sergey is here, one thing I wanted to ask is, so we've talked about lots about read, but one missing component is who has the rights to create or bridge domain to begin with. For example, in our very simple resolver example, the person who deploys the contract can set the record, but it's unpractical for everybody to deploy their own resolver. So we are thinking, I think we have one registry and a global resolver where people can register. In that case, what kind of tools are available if we partner with Chainlink about kind of proving that like I have a right to claim my token.is on specific L2, given that currently L2 doesn't know anything about L1 on our own framework we built so far. I think we did brainstorm a couple of things about using existing chains and stuff, but like with Chainlink collaboration comes in place, what kind of stuff will be available? And also, does that require the users to have the link token to be able to do that in L2?
Yeah, so generally speaking, the use of the networks requires payment and link, and beyond that, you actually have a write functionality, and you have something called keepers. So there's actually a way to verify a lot of on-chain things that you wouldn't be able to verify through simpler systems. So I think what you would do is you would verify certain state or certain ownership, and then you would trigger certain things on the other chain. Generally speaking.
Okay, so until now, I think our biggest kind of assumption was we didn't want to add extra trust assumption rather than what L2 has right now. But now we are saying like every L2, we kind of bridge the naming rights. We have to have link token if we use your messaging rights technology.
Right, but that's a relatively simple problem to solve because there's a lot of dexes to just convert from ETH or USDC to Link or something like that, and a number of people do that pretty kind of reliably and pretty regularly to use the data feeds and the keepers. So that's not really a huge problem. And anyway, all the chains that we're integrated with, Link is launched there and so on. It's one of the first things that happens. So that's just kind of like a backend component that doesn't create any real additional complexity because everybody who's already using feeds and various other things is already just converting whatever token to that in the backend programmatically and paying for the services without a particularly big problem. In terms of the functionality you guys get to that, there's keepers functionality. There's a bunch of functionality to read a lot of things on chain at the target chain and confirm certain things. So there's already a lot of functionality built into Chainlink to prove certain things.
So this comes back to the original question Nick answered about UI that like when we, like as a ENS team, we build in manager and if we want to transition user to, okay, I have a name, I want to resolve this into this optimism or something, we have to think about this kind of DEX integration that, or you first, if you click this button, it automatically, because currently I think we already use Chainlink Oracle for the US, the registration, which is great. And I think that one's great because it's just for the read operation. So we might have to pay Link, but at the end user, they didn't have to go through DEX or anything. But now, by design, I think we have to think about all these kind of DEX token transfer as part of operation, I guess.
Yeah, I think what I've seen is it's largely a simple solved problem in that there's a number of contracts that already do this. So it isn't a problem that deeply needs to be thought about or figured out. The users can pay in various tokens and then they just get converted pretty automatically. I really think this is what's going to be happening for a lot of different infrastructure providers is things will just be converted pretty automatically. So I don't think this is a problem you guys need to solve. I think this is a solved problem where users come with whatever token they want, say, hey, I want to pay whatever token, and then that gets converted for the payment in fees of the target chain, the payment in fees for whatever operations, and that's like a pretty much a solved problem.
I mean, I'm not going to argue that it's technically challenging. It's technically already solved, as you said. It's just like I think we didn't have any that kind of component, so we just have to plan to build these components. Okay.
Yeah, we'll make sure to make that really simple, and I don't think it'll create any issues. We already have a number of people doing that in a pretty seamless way. So that's just becoming more and more seamless.
Yeah. So it's actually time's up, but wondering if there's any burning last question before heading to the show and tell.
I just wanted to jump in and say with the different L2s, what I'm imagining is that there'll be some sort of standardization or control with that UX and with that UI. And if we can just, have these workshops with the different layers of vectors of security, let it be from the L2s or let it be from the bridges, just having like a templated display of information so that, maybe we know all the variables that we want to show to people to say, hey, these are the checks that we can verify. These are the checks that you should know about that we can't verify. This is a link website, just having all these variables put together and then displayed to the user. So no matter what L2 that user is using, the templated system is sort of there for them to know where to find information or know where to expect to see that information. Let it be, that information is coming from, one source or the other. So I guess with, the proliferation of these, the inevitable number of L2s coming, and that could be personal records as well, just making sure that we have a consistent way of presenting that information to people, no matter which L2 is being utilized. I hope that makes sense.
Yeah. Thank you for feedback. Okay, so I think we only have 3 minutes, so we'll get back to the last session. So thank you so much.